And therefore I proved that the photon has zero mass. And I quickly wrote the paper up, sent it off. This is before I learned that you really should wait. That gets you in trouble too. But I wrote the paper up, sent it off to Phys-Rev Letters, didn't talk to Tom Kibble, who I'd been talking with a lot at that time, nor to Dick Hagen, who had been talking about this forever, and sent it off to Phys-Rev Letters, and the next day realized it was total garbage. And the reason it's garbage, of course, is having a conserved current, as you know, doesn't mean that you have a conserved charge, right? It means that if you look at some surrounding surface, that you have a conserved charge only if the charge isn't flowing out the volume. But the charge certainly can flow out the volume if you look at electrodynamics in the gauge that was then very convenient to quantize it in the radiation gauge, right? This is the gauge where you know that if you look at A0, it's just the integral of 1 over r times the charge. Doesn't have anything to do with time. And so even though this is formally conserved, if you just write down the very general spectral representations that you can for this quantity, work them out, it is not conserved in the radiation gauge. There's always charge flowing out the volume. Now, if you insist in the Lorentz gauge, what's called manifestly covariant, so everything looks like it's Lorentz, it is conserved. And you have a wonderful proof that the gauge modes, the things that don't have physics in them, the things that don't have physics in them are massless. Who cares? But that is the key. So this simple thing is a violation of the Goldstone theorem. And I was very upset about this, and I thought, well, it probably won't go. There were various mail strikes. I tried to get it back. Somehow or other, it had gone. And I figured, I'm not going to worry about it because it'll come back, the proofs will come back, and I'll withdraw the paper. The proofs did come back. I was gone. John Cherub, a very nice man, didn't know what I concluded about this paper, and I wasn't around. He opens the stuff from Phys-Rev Letters, looks at their corrections in the punctuation, corrects it, and sends it back to Phys-Rev Letters. Meanwhile, I'm writing up what turns out to be the Guralnik, Hagen, Kibble paper. But anyway, let me, since Chungy rightfully wants to stop me, what the Guralnik, Hagen, and Kibble paper said was that if you look at normal electrodynamics of scalars and you break the symmetry, that, of course, then the perturbation solution no longer is a correct one. There's another solution, and that is a solution which gives the photon mass, right? And by absorbing a degree of freedom from the charged scalar particle that you put in, leaves another particle just sitting around. That's what we call the Beck now. See, I use it twice. In fact, here are the equations in the simplest case. You see there's a mass term on the physical part of A. But let me, since I'm short on time, let me just say this, the way we did it was a very carefully controlled approximation. There were lots of consistency checks. We at that time were assured that it was right as could be, but we spent a long time before we published it because we got a lot of criticism over it. And we eventually published it. And the day we sent it off for publication, needless to say, was also the same day that papers by Brown and Englert and Higgs came in, which had done the same thing, but at that time we naively, but not to take undue holds at my good friends and colleagues, but we naively, and I still think correctly, thought, well, yeah, they sort of picked up the dimensional analysis part, but they didn't get the subtlety of how the degrees of freedom behave, and didn't properly identify that the Goldstone boson was still there if you did a relativistic theory, but it was all gauge. But anyway, all that gets washed away with time. So I went off to give talks on this in various places. I talked early on In fact, at Edinburgh, where they didn't believe this work either, I met Peter Higgs, which was certainly a very nice and friendly man. I haven't seen him in years. And then in the summer, I went to a conference outside of Edinburgh, outside of Munich, met Heisenberg, and gave this paper. And Heisenberg, who was not an overly subtle person, at least with my experience with him, let me know what a crappy physicist I was, and said, this is just wrong, which was sort of funny since, you know, the Heisenberg sort of invented broken symmetries. And I got very depressed, and but hey, Schwinger was there, and Schwinger and I had been friendly because we shared this common interest in cars, and we didn't talk ever much about physics, a little bit, but I didn't want to stand in the line of 20 people outside his office to talk to him, which is why my advisor was Wally Gilbert, who got a Nobel Prize in chemistry. But anyway, and who often has told me, aren't you sorry you didn't work on the problem I told you you should work on? But anyway, Schwinger was there. He ran up to me and he said, Jerry, I've just got the most wonderful car. We must go for a ride. and so we're walking out, and Mrs. Teller comes up, and she says, Julian, what is this I hear about this very expensive car you've bought? And he said, yes, I did. And she said, are you going to it now? And he said, yes. And she said, I'm going for a ride with you. And so we went out to this nice, this gorgeous car, an Iso Revolta, which you see is quite a step out from the Sunbeam Alpine, which you saw me sitting at earlier. And this is roughly the view that I had because Mrs. Teller sat here, and I sort of was almost cheek to cheek with Julian, and very uncomfortable in the back. And he took it out on to the German highway, and it was a nice windy road. And he did an absolutely masterful demonstration of his control of the accelerator and the gearbox. And Mrs. Teller sitting there looking sort of disapprovingly. Finally she says, Julian, in the United States, when we buy such an expensive car, it has an automatic transmission. So there's a lot more to say, but perhaps I should end here and let the next speaker. Oh, there's just one thing that I'd like to show you. Ulrich did this very nice poster, which you've seen out there, and I just would like to ask any experimentalists here, please work hard. I'd like to see the real thing beyond this beanbag toy, which one of Hagen's sons had made up, you see, the GHK boson. There's a similar one for the Higgs boson. So with that, I end.